Today we will talk about elements on the periodic table: atoms, protons, neutrons, mass number, atomic number, isotopes, electrons, shells and subshells. This is the periodic table of elements. Each square here is an element. We said before that elements make matter, which means everything around us, everything that you see is made of these elements. So what you have here, you have a number on the top, a number at the bottom. There is a symbol, a letter, and the name of the element. So what's this number and what is this number? This number here is the atomic number. The number here is the mass number. The letter here is the symbol of the element, and this is the name, hydrogen. So what is an atomic number and what is the mass number? To know what the atomic number is and what the mass number is, we will discuss the atoms that make those elements. So if we break any element into small pieces, into the smallest piece is called an atom. So the numbers here that we see around us, around each element, give us information about the atoms. How the atom of H, or hydrogen, is different from an atom of helium, for example. What makes them different from each other? Each atom is made of protons, neutrons, and electrons. Electrons, neutrons, and protons are the three components that make an. Every element is made of atoms. Atoms are made of protons, neutrons, and electrons. An atom looks like this, like that you see on the screen here, like this representation that you see here. There is a center that we call the nucleus. This center here is what we call nucleus. And these shells outside of it, we call them orbitals. Orbitals. Both protons and neutrons go into the center, into the nucleus. Elements are different from one another because of the number of protons, neutrons, and electrons. So H, or hydrogen, will have a different number of protons, neutrons, and electrons than He, or helium. So number of protons, neutrons, and electrons is the difference between the different elements. So H and He will be different because of the number of protons and the number of electrons that they have. The number of protons and the number of electrons is the same. What does that mean? That means that the number of protons is the same as the number of electrons. Let's say, for example, if an atom has 6 protons, the atom will have 6 electrons. If it has 7, then 7. So the number of protons and electrons is always the same. Protons are positive, electrons are negative, which means protons have positive charge, electrons have negative charge. So protons are positive, electrons are negative. In one atom, the number of protons and electrons is the same. Let's see. If we put one proton, then now we know it's hydrogen. Hydrogen has 1 proton. The number of protons is called the atomic number. So what is the atomic number? It's the number of protons. And it is the same number of electrons. So the element hydrogen will have 1 proton, 1 electron. So what is the atomic number? The atomic number is the number of protons, or that's what we call the atomic number. The number of protons or electrons, it's the same number. That's the atomic number. So the number of protons or electrons is the atomic number. So what is the atomic number? It is the number of protons or electrons, which is the same. The number of protons and electrons is the same, and it is the atomic number. Neutrons have a neutral charge, which means it is positive and negative at the same time. The number of protons is the atomic number, and it's the number of electrons. The same number is the protons, the number of electrons. How about the element that has 2 protons? That's helium. So 1 proton is hydrogen, 2 protons is helium. The atomic number for helium is 2. You see, it is unstable. Why is it unstable? Because it is not even inside in the nucleus. If we put a neutron, now it is stable. Elements can have different number of neutrons, which means helium, for example, can have 2 protons, 2 plus 1 neutron. That's 3. That number, which is the number of protons plus neutrons, is the mass number. Notice how this number is going to change when I add more neutrons. This number here. Notice how it's going to change when I add more neutrons. Let's add 1 more neutron. Became 4. That number here became 4. So helium can have 2 protons plus 1 neutron, and that the mass number will be 3. Or it can have 2 protons plus 2 neutrons, and then the mass number will be 4. So the mass number for helium can be 3 or 4. That's the mass number. So the mass number for helium can be 3 or can be 4. Why? Because helium can have 2 neutrons or one neutral. It always has two protons and one neutron or two neutrons. So 2 plus 1 equal 3, 2 plus 2 equal 4. So that's why there is helium He 3 and He 4. So the mass number can be 3 or can be 4. The atomic number is on the top is always 2. So there is helium 3, helium 4, or helium mass number 3, helium mass 4. What is different between 3 and 4? It's the number of neutrons. These ones can be 1 or 2. 1 or 2. If 1, then it's going to be 2 plus 1, that equals 3, or 2 plus 2, and that would equal 4. So these ones, the two versions of helium, two versions of the same element, are called isotopes. So what are isotopes? Two versions of the same element. Two versions of the same element. Two versions of the same element, but they can be 2 or more, not only 2. 2 or more. There can be 3, there can be 4, there can be 5. Not the same one, not helium, but other ones. Other elements, carbon for example, carbon is 6. This one here has more isotopes, and we will talk about it in a minute. So isotopes are different versions of the same element. They can be 2 or more. They all have different mass numbers. Why do they have different mass numbers? Because they have different number of neutrons. Here is helium 4. 2 plus 2 equal 4. And there is helium 3. 2 plus 1 equal 3. So what is the mass number? It's a number of protons and neutrons. So if you add protons and neutrons together, that will give you mass number. How about the atomic number? What's the atomic number? It's the number of protons alone or the number of electrons alone. The number of protons and electrons is always the same. So for this one here, we have 2 protons of helium. We must have 2 electrons. In helium, it has 2 protons, so it must have 2 electrons. Let's add more protons and see what elements we will have. With 3, we'll have lithium, but again, it's unstable, which means we need more protons. So lithium has 3 protons plus 3 neutrons, and of course it's going to have 3 electrons. You notice that the third electron is not in the first orbital, because the first orbital takes only 2, and then any more electrons will be in the next orbital, and there will be more orbitals outside of these 2. It's not only 2 orbitals, but there are more. So now we know that a lithium atom, or an atom of lithium, has 3 protons and it has 3 neutrons. 3 plus 3, that equals 6, and that's the mass number. So the atomic number for lithium is 3. That's the number of protons or electrons. And the mass number is 3 plus 3, the number of protons plus electrons. And that will be the mass number. Let's add more neutrons and see if there are isotopes for lithium. We can add one more. So there will be 3 plus 4. This means that there is lithium 6 and there is lithium 7. Let's add one more. It's unstable. The differences between the different isotopes are the different numbers of neutrons. There are more isotopes for lithium than 3. So there is lithium 3, lithium 4, lithium 5, and lithium 6. And the differences between them are the numbers of neutrons in the atom. Let's look at carbon. Carbon has 6 protons, 4, 5, 6, and that's carbon. And it has 6 electrons, 4, 5, 6. Now it's unstable because we have only 1, 2, 3, 4 neutrons. We need to add more. 5, 6 neutrons. Now it is stable. So now we know that carbon's mass number can be 12, 6 plus 6, 6 neutrons plus 6 electrons, that's 6 plus 6. Or we can add more neutrons. That would be 6 plus 7. Or we can add more. It says it's unstable. If we look at this table here, we'll find all of these isotopes of carbon. There is carbon 9, carbon 10, 11, 12, 13, and 14, 15, 16. All of these are different isotopes of carbon. All of these ones, 6, 8, 9, 10, 11, 12, 13, 14, 15, and 6. All of these are isotopes of carbon. The differences between them is the number of neutrons.